A steel column does not scream before it fails. It bends, quietly, for weeks, sometimes months. Nobody notices until the floor above it starts to tilt. On July 7, 2026, in the middle of Manhattan, that quiet bending turned into something impossible to ignore. 9 buildings evacuated. 5 blocks frozen. Hundreds of children pulled out of their classrooms, hurried down stairwells without anyone telling them why, not knowing if the tower next door was about to come down on top of them. This wasn't just a construction mistake. It was a chain reaction. One decision. One missing reinforcement. One building pushed further than it was ever designed to go. And by the end of this, you'll know exactly which 2 columns failed, who is blaming who, and why the fix almost came 17 years too late, the same way it did just 6 minutes down the road. Just before 8 that morning, a union steam fitter was working on the 22nd floor. He looked down and saw a crack running through the concrete slab beneath his boots. You'd probably walk right past a crack like that. Concrete cracks all the time. Most of them mean nothing. He didn't walk past it. He went down 1 floor to see what was underneath, and what he found was a steel column bowing outward, visibly out of line, bending like a drinking straw somebody had leaned their full weight on. That one decision to check saved lives. Within the hour, he and a group of contractors were moving people out floor by floor. The fire department arrived, saw enough, and started clearing 5 blocks. By afternoon, 9 buildings stood empty. A television newsroom broadcast live from the sidewalk because its own building had been sealed. Office workers 2 doors down grabbed their coats mid-meeting, no idea when they'd be allowed back. A school on the next street rushed roughly 400 children into the street, teachers counting heads twice, sirens and tape and adults telling them to move fast and not look back. The mayor stood in front of the cameras that afternoon. He said the building had kept moving since crews arrived. Nobody could tell him for certain that it had stopped. Think about that for a second. A tower 2 blocks from Grand Central Terminal, one of the busiest stretches of pavement in the country, and the city's own leadership couldn't promise the ground underneath it was safe. So how did a fully permitted, fully engineered flagship project end up here? The answer was sitting in a blueprint the whole time. Pfizer built this tower in the early 1960s. For 60 years, it did one simple job: hold up desks, filing cabinets, office workers coming in at 9, leaving at 5. Then the world changed underneath it. Remote work gutted office towers across the country. Cities were left holding millions of empty square feet at the exact moment they needed housing. One developer looked at that problem and saw an opportunity nobody had attempted at this scale. Take a century-old office tower, stack 19 brand new floors on top of it. The plan called for more than 1,600 apartments, 400 of them affordable housing, a rooftop pool, a spa, 100,000 square feet of amenities on top of a frame built for typewriters and filing cabinets. The construction loan alone ran $720 million, the largest ever recorded for an office-to-residential conversion in New York City. This wasn't a renovation. This was surgery on a 60-year-old patient, using a chart nobody had updated in decades. And like any surgery, one wrong cut, in one wrong place, was all it would take. But here's what everyone missed. It wasn't just the weight of 19 new floors that mattered. It was where that weight landed. The new upper floors weren't built directly above the old ones. They were built wider, stretching out past the original face of the building below. Picture holding a book flat on your palm, then sliding a second, wider book on top, so half of it hangs off the edge. That overhang is called a cantilever. And a cantilever doesn't just push straight down. It twists. It tries to bend whatever is holding it up, inward, sideways, on top of everything else that column is already carrying. Think of it like standing on 1 foot while someone stacks bricks onto an outstretched arm. You're not just holding weight anymore. You're fighting to stay balanced while you hold it. The columns sitting directly beneath that overhang were the same columns installed decades earlier to hold up nothing more than a roof. They were never built for this, and this is exactly where everything should have been caught. Now, engineers know exactly how to fix a problem like this. You don't tear out the old column and start over, you reinforce it. The design called for welding new steel plates around each original beam until a thin I-beam became something closer to a solid steel box, thick enough to carry the extra floors above it. The blueprints proved it. A column schedule, later released through public records, marked every floor from the 9th up to the 21st for this exact reinforcement. Every floor was checked off. Every floor, except 3. Except, one detail changed everything. The 19th, the 20th, the 21st, the exact 3 floors sitting directly under the cantilever. Photographs of the buckled columns confirm it. No plates, no box. Just the original, bare I-beam, asked to do a job it was never strong enough for. So who missed it? This is where the story gets complicated, because the investigation is still open, and nobody involved has been formally found at fault yet. The structural engineer says his firm's design called for that reinforcement, and it simply was never installed. The building, in his words, was not built to match the plans. The developer tells a different version. He says the project may have missed reinforcing 2 specific columns during construction. Too much load, not enough strength, human error somewhere along the chain. Listen closely to those 2 answers, because they are not the same thing. One says the design was right, and the builders failed to follow it. The other suggests the whole loading calculation may have been off from the start. Based on the evidence made public so far, the record leans one way. The public floor plans support the engineer's version. The column schedule shows the reinforcement was designed correctly, on paper, for every floor that needed it. That doesn't settle who's at fault. Investigators are still working through that, but it does point toward where the gap most likely opened up, somewhere between drawing and steel, in the space where design turns into construction. And standing behind both of them is a private inspection firm, the one the city trusted to walk every floor and confirm that reinforcement work was actually happening. The kind of check that exists specifically to catch a gap like this before anyone ever moves in. The city's own review had run for 2 years. No red flags. On paper, 6 months before 2 columns buckled, this site was clean. But this wasn't even the biggest warning sign. A full year before the buckling, this same job site had already been fined 7 separate times, more than $32,000 in violations. A metal panel fell off the 33rd floor onto a public sidewalk. A worker fell from a ladder, and the injury went unreported, which isn't a paperwork technicality, it's how inspectors know where to look harder. A whistleblower described unlicensed welders and a heavy object crashing through 5 floors of concrete decking. Almost none of those fines were ever paid. Paperwork was filed. Certificates were accepted. The project rolled on. None of those incidents bent a column on their own. But they describe a site where warnings kept arriving, quietly, for a year, before the building itself finally started shouting. But even that wasn't the strangest part of the file. There's one more detail worth sitting with. The weld holding the new reinforcement plates in place wasn't continuous. It ran in short 2-inch sections, spaced a foot apart, up each column. Some engineers who reviewed the drawings afterward questioned whether that pattern was strong enough for this much added weight. And drone footage revealed something else. Where the fireproofing had burned away from one buckled column, the bare steel underneath looked heavily corroded. That doesn't prove corrosion caused the failure, but it means this may not have been one clean mistake. It may have been 3 or 4 small weaknesses, missing plates, a questionable weld, decades of unnoticed rust, all lining up on the same 3 floors at once. Here's what actually kept this building standing. If the load those 2 columns had been carrying found nowhere else to go, the floors above wouldn't have sagged. They would have come straight down, one floor slamming into the next, all the way to the ground. Redundancy. A steel tower isn't a stack of playing cards, where pulling one card brings the whole thing down. Every column, beam, and floor plate is tied to its neighbors. So when those 2 columns lost their strength, the weight didn't vanish, it traveled sideways into the columns still standing, the same way traffic reroutes around a closed lane instead of simply stopping. That's why the floors above sagged, as much as 4 inches, instead of dropping straight through. 4 inches doesn't sound like much. Now picture it as the top third of a 50,000-ton building, slowly, silently sitting down. Once monitoring equipment showed the movement had finally flattened out, inspectors climbed up to see the damage in person. Crews began threading heavy steel shoring, essentially oversized construction jacks, from the 9th floor all the way up, taking the weight off the 2 damaged columns while engineers work out a permanent fix. New York has lived through something like this before. 6 minutes on foot from this exact tower. In 1978, engineers quietly discovered that a nearby skyscraper's wind bracing had a hidden flaw, one that gave it roughly a 1 in 16 chance of collapsing in the right storm. A graduate student's question uncovered it, a simple, "What if the wind hits the corner?" Nobody on the original design team had run through the math. Workers welded it back to safety at night, in secret, while a hurricane churned offshore. The public didn't learn any of it happened until 17 years later, when a magazine writer pieced the story together. This time, there was nothing to hide. The steel bent in daylight, on drone footage, in front of the entire world. Zoom out, because this tower is not an isolated case. It's a preview. Tens of thousands of apartments are currently being carved out of old office towers across this country, cities betting that empty buildings can solve a housing crisis. Most of those projects will finish safely. But every single one is a bet that whoever is doing the work today understands that building better than the people who built it 2 generations ago. On this project, 3 floors out of dozens got missed. That was enough to empty 9 buildings and freeze the heart of Midtown. The investigation into how those 3 floors disappeared between a drawing and a job site is still open, alongside a criminal probe. The developer says the damaged floors will be rebuilt and the project will finish on schedule. An outside engineer says part of the building may need to come down first. Until the investigation closes, both outcomes remain possible, and neither is confirmed. What we do know is this: if that steam fitter had walked past the crack, the way almost anyone else would have, if he'd waited another 10 minutes, finished his coffee, told himself it was probably nothing, this story might have ended very differently. Not with an evacuation, with a headline none of us would want to read. Steel doesn't fail overnight. It fails one ignored decision at a time. A missing plate here, an unpaid fine there, a weld pattern nobody questioned, a crack somebody almost walked past. The most dangerous part of this building was never really the columns. It was everyone assuming somebody else had already checked them. 16,000 people are supposed to call this tower home one day, trusting a chain of decisions they will never see, made by people they will never meet. This time, someone looked down at the right moment. Next time, will anyone be paying attention at all?